like, how to go back and forth between a matrix and a system of equations, and then we'll actually use the matrix to start solving some systems of equations. So, a matrix is really just a way to write a system with leaving out the variables. So when you have an equation, we have x's, y's, and z's. So we have a column for x, a column for y, a column for z. And this is what's called an augmented matrix because it has this vertical line that's representing the equal sign. The way you line things up is very important. Everything in this first column represents the x's. Everything in the second column represents the coefficient of y. These are the coefficients of z's. And then this is what it's equal to. So first one, we have a system of two equations. You basically have a row for each equation. How many columns would I need? The rows are the horizontal, columns are the vertical. We need 3. We need an x column, a y column, and my equal sign. And what you put is, you leave out the variables, you just do the coefficients. So we had a 3 for the x, we had a negative 4y, equals negative 6. And my second row would be 2, negative 3, and that one equals negative 5. And the size of this matrix, I'll talk about that more in the video tomorrow. You do rows by columns, so this is a 2 by 3 matrix. It has 2 rows and 3 columns in it. Do you notice anything about B? Right. We don't have all the variables in every equation. On the first equation we see we do have x's, y's, and z's, so we need a column for each of them. So the first one, it has 2 x's, a negative 1y, a 1z, and it equals 0. Okay, but this second equation, what should I do with this minus 1? So this is like x plus z equals 1. So I have 1x, then what would I have to put? A 0 because there's no y, 1z, and it equals 1. The last equation, so this would be x plus 2y equals 8. So I have 1x, 2 y's, no z's, and it equals 8. So you do need to make sure that the constant is on the right-hand side of the equation. And if you're missing any variables, put zeros for those. I'm going to put a couple matrices up here, and I want you guys to write the system of equations that go with them. So try these two. Write the system. So the first one, 5x plus 2y equals 13. Negative 3x plus y equals negative 10. Did you guys get that? All right, second system would be 3x minus y minus z equals 7. 2x, there's no y, so plus 2z equals 8. The last one would be y plus z equals 0. Nothing says you have to use x, y, and z. You could use a, b, c, or whatever you wanted there. It really doesn't matter. Is that okay? So that's kind of the basics on what a matrix is. Now we're going to talk about solving a system of equations by using a matrix. So I want to preface this with something. Like, I am teaching you how to do this. And so if I'm only giving you 2 equations, it seems kind of silly because it seems more time consuming than substitution and elimination. But think about when we did substitution and elimination, what happened when I threw in that third equation? It got complicated, didn't it? And did we even attempt any with 4 or 5 equations? No. So there's kind of like a sliding scale. If you're just doing 2 or 3 equations, substitution and elimination may be easier. But if you had a lot of equations, a matrix becomes much, much easier. Now, I'm teaching it, so I'm not going to start out the first example we ever do with 5 equations just to prove to you that it's easier that way. So I'm doing examples today that only have 2 equations, and I understand this seems silly because it takes more time this way, but there is a time and place when this is used. When you have a lot of information, then it would be very, very useful. So we're kind of going to play a game. There's certain rules that we have to do, and these rules are very, very important. These are the legal moves. We can swap rows. You know, if you have a system of equations, does it matter which equation is on top? No. So we can flip those rows whenever we want. We can multiply or divide by anything. When we did substitution and elimination, if we were going to eliminate, we would start out by multiplying one equation by something. So we can still do that. And then we can add or subtract rows, just like when we did elimination. We would multiply and then we added those equations together. So we're going to add and subtract rows. And we can do more than one of these things at a time. So jot this down. These are the things that you can do when we are working with these matrices. In this is we want to have a matrix that looks like this. We want the diagonal to be all ones. We want zeros everywhere else. And then we want numbers basically on this side of the augmented matrix. Because if you read me this system, this would be like saying x equals this, y equals this, z equals this. So if we get it in that form, then we have the solution for our matrix. So that is our goal. So we have 3 moves that we can make, 1 form for the final answer. So let's look at a problem. So here's our system. I know you could solve this very, very quickly with elimination, but we are going to try to use a matrix to solve it instead. So my matrix would have 1, 1, the vertical line is for my equals, 8, and then 1, -1, 4. Okay, we are going to be very deliberate about the order we do things because we don't want to undo any of our work later on. So you always have to start in the corner. Your first goal is you need a 1 in row 1, column 1. Do I already have a 1 there? Yes. Then the second thing we want is zeros below that. Okay, so we have to figure out how to get a 0 here. I do want, when we're doing a matrix operation, you have to tell me what you are doing so I know how you're getting to your answer, because there's lots and lots of ways to get there. Which row am I trying to change if I want to make this turn into a 0? That's row 2. So I'm going to say capital R2 equals. So row 2 equals. I am changing row 2. And then I figure out how I'm going to change it. Now my legal moves, we can swap rows. I don't want to do that. We can multiply or divide by something. The only way to get a 0 here is to multiply everything by 0. Do we want to do that? No. We can add and subtract rows. So what if I did row 2 minus row 1. Okay, so I'm not changing row 1. To get row 2, you are taking what's currently in row 2 and subtracting row 1. So 1 minus 1 is 0. Negative 1 minus 1, negative 2. 4 minus 8 is negative 4. Did I lose anybody in that stuff? Is that the only way I could have gotten my 0? No. Could I have done row 1 minus row 2 and also gotten a 0 there? Yeah. So that's why it's so important here that you write out what you're doing, because you could have different looking matrices but still be on the right track. Okay, so our goal. Basically we get our 1, then we get zeros below it, and we're good. Next, remember our format, we want 1s on the diagonal. So I need this number to be a 1. Okay. If I just add rows together, it's going to undo the 0 that I already have there. So instead, we're changing row 2. The easiest way to turn something into 1 is to multiply by its reciprocal. So it's a negative 2, so if I took everything times negative 1/2, I'm going to do negative 1/2 row 2. So row 1 I did not change. Row 2 I am multiplying by negative 1/2. So 0 times negative 1/2 is 0. Negative 2 times negative 1/2 is 1. Negative 4 times negative 1/2 is 2. We are one step from the end. My goal, I want 1s on the diagonal and 0s everywhere else. So I need to turn this into a 0. So which row am I changing? So row 1 equals. How could I turn that into a 0? 1 minus row 2. Okay, so I'm changing row 1 this time. That means row 2 stays the same. So the first row, 1 minus 0 is 1. 1 minus 1 is 0. 8 minus 2 is 6. So now tell me what those equations are. What's the equation for this first row? Equals 2. So we got the order pair 6, 2. I know that that's challenging and you are by no means ready to do one on your own yet. But do you understand what these mean when I write these things? And do you understand how I got my new matrix each time? Let's do another one together. what's my first row? Equals 1, and the second row, 5, 2, 19. What's the size of this matrix if I ask for it? Size is rows by columns. It's 2 rows and 3 columns, so it's a 2 by 3 matrix. Okay. So, first step, we need this to be a 1. Right, there are lots of ways that we might try to get a 1. The easiest option, how did we get a 1 last time when we needed it? Multiply by the reciprocal. Okay, it might lead to some fractions, but it will never be wrong. So if you want to stick with that, that's probably the easiest. Just always, every time you want a 1, multiply by the reciprocal. So which row am I changing? So row 1. If I multiply by the reciprocal, so it would be 1/3, row 1. So I am only changing that first row. And we're just going to keep fractions. We're not going to do decimals. So 3 times a third is 1. -4 times a third is -4/3. 1 times 1/3 is 1/3. I did not change the second one. Okay, what's the next step? We need a 0 below it. Okay, easiest option to get a 0. So we're changing row 2. So let's just start with row 2. It is a positive 5, so we need to subtract 5. But you can't just subtract a number. You have to subtract a multiple of another row. So I'm going to subtract 5 of row 1. So let's look at what that does. We aren't changing the first row. Grab a calculator. Let's make this easy. So, row 2. It's currently a 5 minus 5 times, what's the number in row 1? A 1. So my first entry is 5 minus 5 times 1, which is 0. Second one, row 2. So it's currently a 2 minus 5 times the number in row 1, which is -4/3. Alright, maybe it's ugly, but you have a calculator. Plug it in. Give me the fraction. Alright, the next one. It's currently a 19 minus 5 times the number in row 1, which is 1/3. What does that give you? 52/3. Does everyone understand how I got that? So the first column is good. We move to the second column. You have to get your 1 first and then your zeros. We want 1s on the diagonal, so we need a 1 in row 2, column 2. What is the easiest way to get a 1? Okay, so we're changing row 2. So the reciprocal is 3/26, row 2. So I am not changing my first row. My second row, I'm multiplying by the reciprocal. So 3/26 times 0 is 0. 3 over 26 times 26 over 3. 1. 3 over 26 times 52 over 3. 2. Now what do I need? I need a 0 right here. So we're changing row 1. So let's start with row 1. It's a negative 4/3. So we will have to add 4/3 times row 2, because you can't just add a number by itself. You have to add a multiple of another row. Okay. So, row 1. First one is in 1. I am adding 4/3 times the number in row 2, which is a 0. So what do we get there? 1. Next one, the number in row 1 is negative 4/3 plus 4/3 times the number in row 2, which is a 1. And that gives me 0. Alright, last one. We have 1/3 plus 4/3 times the number in row 2, which is a 2. And what do we get? Did not change row 2. So, what's my answer? Questions right there. We are going to practice this a lot more. Here is what I want you to do right now. There is a handout on Classroom. I want you to skip to, so it's only 6 questions. Only 2 of them are this. I will work through one of those with you, but I want you guys to try it first, okay? So why don't you do number 5 first on your paper? That's the first one like this. And I'm going to give everybody a few minutes to try it, and then we'll actually work through that problem together once everyone has given it a shot on their own. So this is your homework. Do it on your homework page. Do problem number 5.